Navigators, this is 11-4 spheres, day 1. I can calculate the volume of a sphere and solve problems involving the volumes of spheres. Let's take a look at comparing a hemisphere with a cylinder and a cone taken out of it. Let's take a look at these cross sections. The cross section of a hemisphere is a circle. Look at right here, this green circle. Now with this cone taking away the volume from the cylinder, we are going to have this kind of a shape. It's going to be a circle, some area of a circle, take away from a bigger circle. Now the relationship is that the radius is r, and if we draw r right here and then we draw a height to the cross section, let's go ahead and use the Pythagorean theorem to figure out this length here, which I call x. H squared plus x squared is equal to r squared. Solve for x squared and then isolate x squared. So this length right here is square root of r squared plus h squared. So we have just found this radius right here. This radius right here is root r squared minus h squared. Let's go ahead and find the area of this circle. We're going to do pi r squared, and the square root and the square are going to undo each other, and this will be our area. Now let's take a look at the area of this circle outside this circle. Okay, so we have this length right here, which is r, and this radius right here is r. So this length is r, this is r, which means this is a 45, 45, 90 triangle. This is an isosceles right triangle. And so that all the other triangles inside it will also be isosceles. So if this length is h, then this length will have to also be h because they are similar triangles. So let's go ahead and we're going to notice that this radius is h and this radius right here is r. Let's go ahead and figure out the area by taking the area of the big circle, pi r squared, minus the area of the small circle, pi h squared. And if we take out a pi, we're going to get this. Now I want you to notice that these are both the same. So these cross sections are the same. The heights are the same. So Cavalieri says if the cross sections are the same area, the heights are the same area, then the volumes will be the same. So this is what I'm trying to tell you. I'm trying to tell you that the volume of the half sphere is equal to the volume of the cylinder minus the volume of the cone. So let's take a look at the volume of the cylinder. It's pi r squared and the height is r. And the volume of the cone is 1/3 pi r squared times r. So if you have a whole thing, take away a third, you're going to have 2/3. So the volume of half a sphere is 2/3 pi r cubed. Well, if half a sphere is 2/3, then the volume of a whole sphere will be 2 of those, so that'll be 2 times 2/3 pi r cubed, and so then the answer will be 4/3 pi r cubed. Let's take a look at the next slide, and that's what the next slide says. It says that the volume of a sphere is 4/3 of the product of pi and the cube of the radius of the sphere. Let's go ahead and practice a problem. So we're going to write volume is equal to 4/3 pi r cubed. There's only one number to put in a sphere, and that is the radius. So we're going to put 13 here. And when I take 13 squared, 13 cubed, and then I times it by 4, I am going to get 8,788 pi, and then divided by 3. So I just took 4 and I multiplied it to this number, and that's how I'm getting this. And then we're going to write units cubed because I didn't give you feet or centimeters or anything like that. Okay, let's take a look at this. We want to find the volume, and this is a hemisphere. The volume of an actual sphere is 4/3 pi r cubed, but this is a hemisphere. So the volume of a hemisphere is going to be half of that, so that'll be 2/3 pi r cubed. I am going to put 4 in there, and 4 cubed just means, 4 times 4 times 4. So we're going to multiply all those 4s, and the 2, and we're going to get 128 pi over 3. And again, it'll be units cubed since I didn't give a units. Units is the generic form. Okay, let's find the volume of a basketball. So volume is equal to 4/3 pi r cubed. So we go 4/3 pi. Now this is not a radius, so you're going to have to take 9.55 and you're going to have to divide it by 2 cubed. Okay, so let's go ahead and put that in our calculator. You might want to use your fraction key or anything that'll help you keep everything straight. And this is going to be 9.55 divided by 2 to the 3rd power. And I'm getting approximately 29,186.9 inches cubed. So that's how many cubic inches are in a basketball. Okay, this is our last problem, volume of a composite solid. So we have two things, volume of a hemisphere, and we have a volume of a cylinder. And we're going to put them together, and that'll be our composite. So this is going to be 2/3 pi r cubed, because we only want half of it. So 2/3 pi. Now, if the whole diameter is 2, then the radius is 1. So this radius will be 1. I'm going to put a 1 here. So this answer will be 2/3 pi. This is area of the base times the height. The area of the base is pi r squared times h. Our radius is 1 and our height is 3, so this is going to be 3 pi. So the volume of the composite will be equal to 2/3 pi plus, I'm going to write 9 pi thirds because 9 divided by 3 is 3. And then that'll be, I'm trying to get a common denominator. And there we go, meters cubed. And that's the end of the screencast.